గుణము.
దేశ పురోగతిని పరుగు పెట్టించే ఇంజనీర్లుగా కంకణం కట్టా. భారత కళల్ని సాకారం చేసే భారత వైజ్ఞానిక శిల్పులం. విశాఖ ఉక్కు, రాయలసీమ థర్మల్ మా సామర్థ్యానికి సాక్ష్యం.
శ్రీహరికోటే మా మేధో శక్తిని గగనతలాన విజయంగా లిఖించింది.
ఇంజన్లు, రాకెట్లు, మిసైళ్లు, రోడ్లు, రైళ్లు, వంతెనలు, నీటి పారుదల, విద్యుత్తు, కంప్యూటర్లు.
ఇలా అన్ని తెలిపెగా మా వైజ్ఞానిక నైపుణ్యాల పరిణతిని. ప్రతి ఆంధ్రప్రదేశ్ ఇంజనీరు ఒక వైజ్ఞానిక యుగవారధి రూపం.
భారత కళల్ని సాకారం చేసే భారత వైజ్ఞానిక శిల్పులం.
ఎగురుతోంది ఐ జెండా, నిత్య ఆవిష్కరణల జెండాగా. ఎస్కి శిక్షణ కేంద్రం, జ్ఞానరాశి ప్రకాశం, ఇంజనీరింగ్ విభాగాలు ఎన్నున్నా అంత ఒకే కుటుంబం. ఈ ఐ జెండా పెంచిందిగా ఆంధ్రప్రదేశ్ గౌరవం. ఇది మా ఆంధ్ర గీతం, వైజ్ఞానిక రాగం. భారతదేశాన్ని ప్రపంచ అగ్రగామిగా నిర్మించే విజ్ఞాన శ్రామికులం.
ఆంధ్రప్రదేశ్ ఇంజనీరు నీవే కదా, భారతదేశ జ్ఞాన సంపద.
జై ఇంజనీర్, జై జై ఆంధ్రప్రదేశ్, జై జై
ఆంధ్రప్రదేశ్.
Thank you, Anil. Now I request Chairman of IEI, Professor MLS Devkumar sir, to address the gathering.
Yeah, thank you, Dr. Jitendra Gaur, who is the convener of this program. At the outset, I am very much thankful to Institution of Engineers, Andhra Pradesh State Center committee members for planning this activity, which is very pertinent for today's times. So, at the outset, I welcome all the members who are joined on this Google Meet and as well as through YouTube channel for this Institution of Engineers Andhra Pradesh organizing program, which is oriented towards career development and career awareness program, which is being delivered by our chief guest and keynote speaker, Dr. M. Madhusudan Reddy.
హలో.
సార్ కనెక్షన్ లాస్ట్ అయింది, వస్తున్నారు.
థ్యాంక్ యూ. పంపించండి, 500 పంపించండి.
హలో, జితేందర్ గౌడ్ సార్.
సార్.
సార్, కంటిన్యూ ద నెక్స్ట్ వన్ సార్.
Okay, sir. So, I introduce the speaker. Dr. M. Madhusudan Reddy Garu is currently working as Senior Assistant Professor in the Department of ECE from G. Pillai Engineering College, Kurnool. He completed his MTech from SRM University and has awarded the PhD from JS University in 2023. He has an extensive academic experience of 18 years in the Florida College, where he has served in various academic and administrative positions. Dr. Madhusudan Reddy has made significant contributions in research and academic activities. He has published more than 15 research papers in national and international journals, including 4 papers indexed in IEEE Explorer and 3 SCA indexed papers. He has also 3 patents to his credit and has actively participated in numerous national and international conferences. He is also an author and has authored 4 books in the areas of VLSI and operating systems. His teaching and academic expertise covers various subjects related to VLSI design, catering to both undergraduate and postgraduate students. With his rich blend of teaching, research, publication, patent, authorship, and administrative experience, Madhusudan Reddy sir has made valuable contributions to this field of ECE, particularly in the areas of VLSI design and related technologies. I welcome you, sir. for this speech, and I hand over the session to Madhusudan Reddy, sir. Thank you.
Yeah, thank you, sir. Thank you. Thank you for everyone. Thank you for having me. Moreover, thank you so much to IAI and Adinarayan Reddy, sir, for accepting me and
Thank you for
giving me,
accepting, Mother.
sir, sir, accepting and giving me an invitation to present a seminar on this day, August 15th. Thank you, sir. Thank you. Thank you, everyone. So my topic today is actually career opportunities in semiconductor. Before that, I would like to give introduction to what is this semiconductor and integrated circuit design. So I start with a simple question. I start with a simple, not question, it's just a guesswork. Can anyone, of course, answer is there. Can anyone identify the image? Is it visible? Sir, is it visible, sir? Screen?
Yes, sir. Yes, sir. It is visible.
Yeah.
Yes.
Yeah, just identify the image. There is a question. Today I'm starting. This is actually 5 MB hard drive being shipped by IBM somewhere in 1956. If you see the size of the megabyte, that is 5 into 1024 into 1024. That is 5 into 2 power 20. 5 into 2020. Nowadays, this type of size generally comes for transportation of a car, for transporting car. But those days, that is exactly before 70 years, the size of the MB, 5 MB is this way. Now, what is integrated circuit? First thing, what is integrated circuit? I will go through each and every division, bifurcation in this one. I start with one integrated circuit to thousands and thousands and thousands of integrated circuit, and on what basis they are divided. So here V stands for very and large scale integration. We have divisions: SSI, MSI, and large scale integrated circuit. First, I go through first three ones. SSI means 10 to 100 transistors. 10 to 100 transistors. If you go through any decoder, if you go to any decoder or any 8-bit arithmetic logic unit, that is the best example for the SSI devices. And here, range of transistors is 10 to 100. 10 to 100. Moreover, for two transistors were required to design one inverter. Two transistors were required to design one inverter. And 4 transistors were required to design NAND or NOR gate. Moreover, to design AND OR gates, we require 6 transistors. Out of 6, 3 are PMOS and 3 are NMOS. So 7400 series I have taken example because everyone is comfortable with this series. 7400, 02, 04, 06, 08. We do have 74138, 74194 series. Next comes medium scale integrated circuits where the range of transistors are 100 to 1000. Say a simple 4004 microprocessor. 4004, that is the first microprocessor from the Intel Semiconductor Corporation. That is the example. And here there is 74000. There is addition of 0. The meaning of this one is we may go with the 74381 series. The next one is where the range of transistors are 1000 to 10,000 transistors. And they are termed as large scale integrated circuits. Here the best example is what we did or what some of the, maybe if some of the students were there here. 8085 microprocessor, 8085 microprocessor, which consists of almost 6,000 transistors to design it. It has so many functions embedded in that 8085 microprocessor. Of course, there is another microprocessor 8080. They comes under this category of integrated circuits. Now the next one, which we are using today for our CPU, for our laptops, for our smartphone devices, whatever you take one electronic instrument, what we are using today is, which is greater than 10,000 transistors. That is very large scale integrated circuits, very large scale integrated. You take any example. I start with 286 microprocessor and 386, 486, and Pentium 1, 2, 3, 4 series of processors from the Intel. Further, I am going through nowadays i3, take any generation, i5, any generation, i7, i9. They comes under very large scale integration, very large scale integrated circuit. On the other hand, we have AMD Ryzen 3, Ryzen 5, Ryzen 7, Ryzen 9, which comes with much of multi-threading concept, that is known as everything is greater than 10,000. Here the meaning of 10,000 transistor is it may be 10 into 10 power 6, 10 into 10 power 6. And recently we had one integrated circuit which is 1000 into 10 power 6 transistors. Almost that is 10 power 9 transistors within area of 2 centimeter by 2 centimeter or 3 centimeter by 3 centimeter. So these are the main divisions. So different parts of the world, Asia, Europe, USA, uses different terminology. Here I have gone through another one, that is ultra large scale integrated circuit. This is the terminology generally used by Japanese. Of course, we do not use this type of ultra large scale integrated circuit, but only in Japan they use ultra large scale integrated circuit. Other parts of the world, apart from Japan, it's a very large scale integrated circuit. Now, what is the process? What is the process of making this integrated circuit? First, sand is taken, that too a sand which is very much of crystalline in nature, with a chemical SI, that is 14, 1s2, 2s2, 2p6, 3s2. I think I am right. Okay. That too we need a very much regularized crystal. Remember, the sand which we are getting somewhere in Thar desert, maybe in some other parts of the deserts, may not be suitable for the fabricating integrated circuits. We need to go with some sand which is very much of very good quality. The sand is heated at the temperature of 1280 degrees centigrade. That is the melting point of the sand, 1280 degrees centigrade. We do have separate process to melt this sand into a known as, this process is known as by using a Jokoralski. Actually, the name of the processor is, it's a oven actually. It's a Jokoralski process where the sand is heated up to 1280 degrees centigrade, of course, 1300 degrees centigrade, where this is known as, the second picture is known as ingot, INGOT. It is known as ingot. From this ingot, we are going to make everything into very thin slices, very thin slices. Further, after going through so many processes like photolithography, etching process, then photo masking, and further so many steps were there, which I am not going into deeper today for today's session. Then the wafer, it is known as wafer. Wafer is nothing but group of integrated circuit on which the integrated circuits were etched. Wafer is, once again, wafer is nothing but a circular one on which integrated circuits were etched. Further, these wafers were cut into a regular square shaped. If you see that wafer, it's everything is square shape. Everything is square shape. If you observe our processors, most of the processors are of squaring nature in this way, 2 centimeter by 2 centimeter, maybe 3 centimeter by 3 centimeter. Of course, it too comes with a thickness of 2 mm, 3 mm, and 5 mm, 7 mm, depending on the chip density. Chip density. If I say in width, length, and thickness, I go in this way: 3 centimeter by 3 centimeter into 0.03 centimeter. Once again, further they made into a package format. Further, they are etched by using one of the very famous technique that is known as surface mount technology, SMT, where the routing is performed, and further it is known as IC chip. This a bit just touch upon, just I am touching upon, I am not going into deeper concepts today. So what are the semiconductor devices day to day we see? Best example for students when it comes a resistor. Already every one of you aware of resistors, how to detect what is that resistance. Of course, we do have capacitors and the diode, triode, op amp. They are day-to-day uses for the student, a third year or second year or first year BTech students. Further, if we go to third year and fourth year further, MTech studies or research, we may go and experiment. We may go and do experiment by using very high-speed integrated circuits. Like I give some of the example: TMS 320 C54X. Okay, TMS 320 C54X, which is one of the very good digital signal processor. Okay, something which is used to do some processing in digital signals, maybe convolution, maybe correlation, maybe go with any MAC operation like multiply and accumulate unit, MAC. It is known as MAC unit. So this comes under DSP processors. Everything is embedded in the DSP processors. I go through some of the examples like TMS 320C54X and TMS 320C6711, and further advanced one TMS 320C6713 when it comes to academics. And there is another figure, transistors. We do know about transistors. Further, the 5 MB, which is in 1956, that is almost 70 years. The same, just see the next diagram where the 4 TB HDD hard disk device. See the just thickness and the size of it. Maybe most of you do have 1 TB HDD, maybe 2 TB. You can imagine what is the difference in the size. And further, for reference, we have kept one passport with more than 36 pages with a thickness. Almost the two having same size. That's why the passport is given to that hard disk drive. 1 TB passport, 2 TB or 3 TB, 4 TB. Nowadays, instead of hard disk drives, we are getting most of the market is flooded with SSDs because of their high speed, almost 150 Mbps solid state devices. We have, but a bit cost 1 TB, 2 TB, 3 TB, 4 TB SSDs. These are the integrated circuit is evaluation. Further, maybe most of you know the first computer. Actually, the first computer, when you ask me, the first computer is at the time of World War I, that is by Turing. It's known as a Turing machine. It's much of mechanical components, that is known as a Turing machine. But here the difference is, this is almost by using some latest components at that time. Charles Babbage, everyone knows about this great person, a great mathematician and a programmer, and he made one first computer. And nowadays, see the difference in the size. Something which is very huge, just a room size, almost it's a room size. Moreover, the peripherals which are connected to this one is almost occupies another very tiny room. And 20 to 30 expert engineers or mathematicians are required to operate the first computer. Whereas nowadays, just observe, it fits in your bag. It fits in your a simple bag, and just one person is enough to operate it with a good programming skills. And further, and I will slowly why this is happening. Something which is room size is changed to just something which fits in the bag, or something which is you can carry it. Now, what is the flow nowadays? What we are going through is starting with the chip specification. What is meant by chip specification? The vendor comes with what are the inputs, outputs, and what is the functionality of that one, and what is the speed at which the IC need to be worked. Everything, he'll be having something in his mind. Further, based on that one, engineers go and design the design entry. This is actually known as coding, hardware description language. I repeat, hardware description language, which is of two types. The first one is very high speed integrated circuit hardware description language, which is developed by US Department of Defense under DARPA Foundation, that is Defense Advanced Research Projects Association. And they have given contract to three companies in this world. One of the companies is IBM, and the second one is Texas Instruments, and the third one is Intermetrics. The three companies came with one hardware description language in 1983. They named this one as VHDL. That is the first one in 1983. Further, this very high speed integrated circuit hardware description language went through so many revisions, and they standardized. Nowadays, what we are using is not VHDL, it is Verilog. It's a verification. It is for the verification. Of course, we do have coding and everything in that one. This is from the Gateway Design Automation, GDA. The name of the company is Gateway Design Automation. Of course, the starting is 1983 itself. But those days, the VHDL is very high standard. Even if you go to nowadays, DRDO or ISRO, NASA, they do work with this VHDL only. They are not into Verilog, because Verilog is not that much secured, whereas NASA, DRDO, ISRO considers this VHDL as a very secured one. Further, after writing coding, it is converted into by using some of the CAD, computer aided design chips, or electronic design automation tools. Example, I give some of the examples. Vivado, further in further slides we do have those concepts. Just I am giving touch upon Vivado, VIVADO. They have different versions, and they are from the company AMD. If any student is there in the this seminar, they can go through amd.com website. They can register. They can download this one, this Vivado EDA for free. That too, Webpack. Remember Webpack. It may be something around 10 GB, sometimes 18 GB. If you go to entire package, 18 GB, because it performs so many tasks. It gives so much opportunity to a student to do his BTech or MTech projects, and even for the PhD students. Further, it goes through so many processes, like just slide. Next one I'm going through. Now see this one. Once again, I go back. System specification, already we have seen. Design, functional design, circuit design, and here we do go through CAD. Here everything is good. We do go through CAD designing. And this physical design, once again, bifurcated into partitioning, floor planning, placement, and the clock tree synthesis. It is known as CTS for the routing and the timing closure. Remember, dear students, here each and every block, like system specification, architectural device, design, functional design, circuit design, and physical design bifurcation, see it, partitioning, floor planning, placement, CTS, SR, TC, further physical verification. In each and every bifurcated, whatever I have indicated in the blocks, everything comes under job category. Everything comes under a career opportunity, nothing but a job opportunity. Further, I'm going to the previous one. Partitioning of the chip, that is, partitioning is nothing but if we have any cores in that one, like cores are nothing but when I go to somewhere around 1990s, we do have core 2 DO, core 2 DO, and dual core, and quad core. That means 4 cores. Then nowadays we have octa core. Of course, if you are going with server systems or any high speed servers which are used in the data centers, they comes with so many cores. And partitioning of the chip is very important, and the opportunity in this area is very, very huge, very, very huge. And after partitioning of the chip, and here there is one terminology, that is the DFT, design for test. Further, I make this one as VDFT, VLSI, design for testability. This is one of the area where so many engineers were required nowadays in India, especially. So many engineers were required in this area, DFT, VDFT. The DFT itself is a very, very vast subject. Moreover, the chip has to go through this DFT at each and every stage, because at any given moment, if something goes wrong, the entire chip process is going to be a big disaster, which uses to company crores and crores of rupees. So at the partitioning, at the RTL design, at the design entry, the chip has to go, the system has to go through DFT process. Further, we are going with floor planning, nothing but what is the arrangement of the gates. Nowadays, instead of gates, I use the word combination of so many muxes, combination of some memory, how to plan them on the given chip area, that is centimeter by centimeter. What is that position of the combinational logic block? Further, we are going through one of the very good concept, CTS, clock tree synthesis. In this area, so many engineers were required, and this is one of the difficult area. I say one of the very difficult area. The meaning of this one is it requires so much effort to get into this CTS, to get into this CTS, clock tree synthesis. Very, very few engineers in this area. So those who are very good at digital design and circuit design, they can opt for this area, CTS. After CTS, what we are going through is a routing concept. Routing is nothing but the connectivity between the each and every core. Of course, the internal components, everything comes into picture. This is known as routing. Further, we are going with the verification, final verification. You may replace another word here. Instead of verification, once again, you can go through VDFT, VLSI, design for testability. By using so many algorithms, the IC is tested. The IC is tested. So after testing this one, there is another one, GDS2 format. So nothing but a graphical design system 2 format. So this is the entire process is starting from specification. This is simply known as in integrated circuit terminology, specification to GDS2. Some of the websites, if you refer, or some of the training companies nowadays, they are going with RTL to GDS2 specification. Even if you go to IIT NPTEL videos, they have one certification course, that is RTL to GDS2. That is one of the certificate course. You can do your work, and you can gain so much of knowledge in this area, starting with RTL to GDS2. Next, same thing, but put it in a bit different way. System specification, architectural design. Here, architectural design, and further functional design and logic design. Most of the ECE students were aware of this one. functional design and logic design. Then comes circuit design. Maybe this may be in the form of sum of products or product of sums. Further, if you go through the left hand side figures, there is the second block diagram. Observe it. Entity, test, port A, like next end entity. This is how the representation is in the VHDL. Yeah, just right. This one is VHDL. So here program starts with library IEEE use IEEE dot std underscore logic underscore. So due to space constraints, I am going in this way. Now entity name of the entity is port. Here you get port declaration, that is inputs and outputs. Next end name of the entity. Next comes architecture part. Architecture, name of the architecture of entity name is here. You'll be having statements and further end name of the architecture. This is one way of writing program. This is VHDL. If you are going through very if you are going through Verilog, this is very simple. Writing a program is similar to your C program. And when it comes to Verilog, the writing of the program is very simple. No need to include any libraries. Just start in this way. Module. And this one is similar to C or Java. Module, name of the module, start and give here what are the inputs and outputs. Next, direct statements. Some statements come. Statement 1, statement 2, statement 3. Now end module. This way the Verilog programs goes. Verilog. No libraries included. Further, after going through this one, we are going through the circuit design concept, which is indicated here. Circuit design. See, not we are doing now. We cannot do. We are working with the thousands and thousands of transistors. The CAD or EDA, that is computer-aided design or electronic design automation tool, performs everything. Next, go through this one, physical design, which covers the partitioning, floor planning, placement, CTS, routing, and the timing closure. Nothing but it gives about timing specifications. If I say it get in the form of the SLAT time. There is another word, worst case scenarios. Here one need to go with what is that worst case scenarios. Of course, after this physical verification and the sign off. Sign off is nothing but almost the entire chip is ready to go to fabrication. Here there are three words which are very useful nowadays for BTech and MTech students, which is very much for job role. That is DRC, design rule check. Next, there is another word. These two are very important terminology. Layout process, schematic. Schematic. These two need to be performed without fail. Further, of course, there is GDS2 already I have specified there, and fabrication, packaging. These are the steps involved in entire IC process. Next, what are the design abstract levels? Of course, we do know what is that system. We do know what is that system. Maybe a microprocessor. Start with a microprocessor or any microcontroller. Further, the designing part here. Now here, what is that gate level and how to represent in terms of the gates. That is, if I draw this one, assume the inverter, input, output. The inverter functionality is if I give 0, we get 1. If I give 1, we do get 0. We see how this is possible. Actually, a PMOS transistor and another NMOS transistor. These two are connected. Both are the gates. These are the gates. Gates of the PMOS and NMOS. They connect these two. And this is the output. Give it to VDD and ground. This is the input section. VDD, this is PMOS. It comes with a specific width by length ratio. Especially for students, this is very much useful for your further studies. Like if you go to research also, these width and length concepts are very important. This length is nothing but, if you see here, this diagram, this is the length. This length may be 2 nanometer. Nowadays, we are working with 2 nanometer. The current TSMC is working with 2 nanometer. If I go back to somewhere around 22 years, it started in this way, 360 nanometers. 360 nanometers. Of course, there are so many 240 nanometers is there, 270 nanometer. If I am exact, 180 nanometer, 130 nanometer, 90 nanometer, 65 nanometer, 45 nanometer, 30 nanometer, 22 nanometer, 14 nanometer, now 9 nanometer, 7 nanometer, there is 5 nanometer. Nowadays, this is 2 nanometer is the distance between the source and the drain. This is 2 nanometer. Just imagine what is the complexity of the MOSFET. This works in this way. Just I go through further, and this works in this way. This section is known as pull-up network, and this NMOS section is stack of NMOS. Here just I have indicated one NMOS, but in real time we do have so many NMOS transistors, may be connected in series or parallel. Pull-down network. This is the overview of what are the design levels of abstraction, and the complexity is increases when you start from base to here, increases. Okay, and here we do have two types, that is bottom up and top down. These two are methodologies. Top down and bottom up methodologies, these two are. Further, what are the factors considered in the design? This is almost most of the engineers and we, not engineers, even we worry so much about this one. We need everything which consumes very much less power, and we like nowadays the power consumption is very important because we are using portable devices. The battery capacity, if you take any portable device like a smartphone, example, smartphone, maybe 4,500 mAh to, of course, there is 6,000, 7,000, so many. So the bigger one I have observed nowadays is 10,000 mAh. Then another company came with 10,001 mAh. So this is how the battery for the portable devices. On the other hand, if you go to any simple laptop, maybe they give 45 watt hour or 67 in this one, depending on the, are they 3 cell or 6 or 9. Nowadays we are not getting this 9. Nowadays what we are getting is these two variants, and the power plays very important role. At the same time, speed and size, these three are. On the other hand, the cost must be minimum. So the integrated circuit companies has to maintain everything on par what required for the customers, what required for the market. When we say power equation, in general, we write power, the equation is in this way. But in integrated circuit, the power equation is changed to alpha C V square F. This F is clock frequency. V is nothing but VDD. And in this capacitance, this capacitance is very important, because apart from your body capacitance, gate capacitance, source capacitance, we do have so many parasitic capacitances here. So a designer has to reduce everything, and this is nothing but switching activity. That is, an event occurs on the input is known as switching activity. Maybe 0 to 1, maybe 1 to 0, maybe so many changes with the so many bits, like 65,536 is the minimum number with which we are working nowadays. Equal to 2 power 64 we are working. Next comes speed. What we require and what we need is very high speed in this way. 4 gigahertz, 2.4 gigahertz, 5 gigahertz, 2.1 gigahertz. The speed must be very high, and size as compressed as possible. Size must be as compressed as possible, and we are looking for smartphones worth less than 20,000, 15,000. 15K, 20K is considered nowadays as a is 15K, 20K. We are getting very good for smartphones in this range. So these three are very important parameters for the integrated circuit engineer. Moreover, the research nowadays, what says is, if you refer IEEE research papers, they give maybe IEEE or whatever it may be. Just I'm giving one example so that students are aware of this point. IEEE papers, very good research papers. What we are getting is high speed and low power. Nowadays, researchers are adding, you take anything like 4-bit adder, a barrel shifter, an arithmetic logic unit. Everything before it, they are adding high speed and low power. Say arithmetic logic unit. Once again, high speed and low power DSP processors. DSP processor. This became house name for the researchers in the field of integrated circuits. High speed, low power, everything. Not only low power, there is another word introduced, that is ultra low power. Ultra low power. Imagine where we are. The whatever Charles Babbage or ENIAC computer or a Turing machine used to consume megawatts of power. Nowadays it is became almost milliwatts or microwatts of power. Remember, these are very, very important area for job fields. Of course, there is another word here. Integration reduce manufacturing costs. Of course, no manual assembly, because it's not possible. It's not possible for manual assembly. Everything is performed by CAD. Just I have taken one of the IC. This is nothing but which you can expose to UV rays. You can expose to UV rays. Now, what is the timeline of electronic devices? Already started with the transistor, then IC. So whenever I say IC, the first person we need to remember is the great person who invented this integrated circuit when he was working with Texas Instruments Company. His name is J.S. Jack S. Kilby. He is the person who found integrated circuit. He was working with Texas Instruments at that time. Next, there is a generation of processors, DSP processors, as I said, TMS 320C 54X. 320C 6711, C 6713, so many types are there. Then FPGA is nothing but which is reprogrammable there. Feed programmable gate array. Field programmable gate array, which is very flexible. The famous one for academics is JetBoard. JetBoard is a famous for academics. And of course, we do have Pink board also that works with Python. Remember, this is JetBoard. We do have like JetBoard is there is another version, ZYNQ FPGA. There is another one, PYNQ. This is for the Python. Remember, a Python can be we can do program with Python also. We need to upgrade our skill set. FPGA, and there is another word, ASIC, nothing but application specific integrated circuit. Maybe a example, a microwave, the IC in the microwave oven, or just a toy. Everything comes under these ASICs. Now there is SOC, there is specified SOC, nothing but system on chip. There is programmable system on chip. Now there is MP SOCs nowadays, multiple programmable system on chip. It keeps on going. It never ends. The integrated circuit, the semiconductor industry never ends. So just I have taken one picture, how the integrated circuit. See the 20 nanometer with after zooming so many times. This I have taken from the internet. I have taken from the internet. Okay. Now, different. What is the ones which is crores and crores of rupees to design a computer at the time of Charles Babbage mission or ENIAC or maybe a Turing mission? Nowadays we are getting just for 50,000, maybe 1.5, maybe 1.8 or 2.2 100K, 2.2 100K. Most of the i5, if I say i5 fifth or seventh generation, we are getting for 60,000 to 70,000 rupees. So author compared with one transistor equal to one mineral water bottle in that way. This is just for comparison purpose. What is this domain? So, strictly speaking, circuit design, programming, and analysis. Here, this is a bit on the background. I change it to white. So, yeah, okay. No problem. Circuit design, programming, and analysis. Next, further, what are the tools used to design? The next slide we are going to see, no problem. CAD tools and technology and everything integrated together. It's just like a Venn diagram in mathematics. Everything on a universal set, a Venn diagram, how the design, CAD, and the technology. We go through the next slide quickly. Now go through this one properly. The process of designing. Here, each and every we use tools like synopsis, cadence, Vivado. Of course, purchased versions. What I am speaking is purchased versions, and there is active HDL. These are the very famous front end and back end. Remember, we have two categories here: front end and back end. The synopsis, cadence, Vivado. Vivado, you forget about it. The first two, synopsis and cadence, are for the both front end design and back end design. Here I am going to differentiate what is that front end and back end. First, go through this one. System level design. It's a one of the job, one of the career opportunity. Next, architectural design, a bigger one. One should be very funda in digital design. Otherwise, this job is very difficult job. Architecture. Next, digital system design. This is another career opportunity. Then here most of the electrical part is performed here, and next year to here. So మీరు చూసే ఉంటారు, if you observe in Bangalore or some other institutes, they go with this way. Analog, one of the very good career opportunity, layout engineer. The next one is just simply the company specify in this way. Companies means maybe if you refer to some job websites, layout engineers. So this is about layout engineers. Next, semiconductor design, that is at the fabrication. The next year gives much more career opportunity to you. Now, digital design. See here, what is that engineer role and how it is divided. For engineer role, RTL design engineer, and here RTL is nothing but register transfer level. Transfer level. So this is one career opportunity. Of course, the next one is verification. And this is known as some websites or some textbooks verify this one as design verification. Remember, it's a design verification. The next one we do have, that is testing verification. Next, synthesis and STA engineer. STA is nothing but static timing analysis. So here the synthesis, I give the what is the basic definition of the synthesis. Whatever program you have written in way of by using either VHDL or Verilog is converted into appropriate netlist is nothing but process of synthesis. It's known as process of synthesis. A great career opportunity here Yes. Next, design for testability engineer. Already we have seen in our fifth slide where DFT engineer is there. And what are the appropriate tools here? This is ISE. Here I have written because a basic one is this one. Nowadays, this company and AMD work together. Now, AMD, Advanced Micron Devices, AMD, and both are same companies nowadays. The website is www. You can register in this company. You can download some of the CAD. You can register through this website and you can download Vivado, whatever I said, that Vivado. Maybe we'll be having so many versions here, so many versions. The latest version so far what I have seen is 2026.2 and 3. Okay. (2026.2) and 2026.3. But remember, you need to have very high speed internet and everything. The next one is Questasim is actually not in India. Generally, some of the companies in Europe, they use this concept of Questasim. And this one is from Cadence. This one is from Cadence, used for the verification purpose also. So what are the skill set a student has to require or aspirant? He should be aware with Verilog and not specifying nowadays VHDL because even universities or none of the institutes are going through this one because not most of the 90% of the faculty don't know what is this VHDL. What they know is a bit of Verilog and further. As I said, XAM, System Verilog, Universal Verification Methodology, UVM means. And what are the tools here? Cadence. In this Cadence, we have once again different flavors like Genus, Conformal, and in case of Synapses, we have Design Compiler. Of course, we do have Power Synthesis, Power Simulator for different purposes. On the other hand, we do have one company, Mentor Graphics. Mentor Graphics. The website for this one is mentor.com. You can go through this website and you can download a software known as Model Sim SC Student Edition. You can download Student Edition for this one. All these are career design, career objectives in the semiconductor, in the form of design specification, in the form of functional description and simulation, in the form of functional verification. And remember, up to these 4 categories, this is known as front end. This is known as front end. The other 5 are known as back end design. Back end design. Front end design, back end design. For back end engineer and back end design, you need to have much more expertise, much more command on the subject, especially subjects like basic electronics and digital design are very important. Apart from this, you need to have CAD or EDA and create test pattern that comes under here. We are going to use so many types of algorithm in this test pattern, which we will see some other time. Then static simulation. So these are the factors which are known as backend. We see what happens after. Now, what is hiding here? So up to static timing analysis I have covered. Up to STA I have covered. Up to STA I have covered. Now what comes next is this one. Now these are the under fabrication. under fabrication. So this is fabrication where on the wafer, so many indicators. We do have a fabrication unit in Chandigarh. If we go to Chandigarh, we do have one fabrication unit, that is semiconductor complex limited. SCL. This is in Chandigarh. But this is not for the commercial purpose. What they make is 8-bit counters, maybe up counter. Whenever you go with counter, say it as up down counters only, or like carry lookout adders. Generally for the academic purpose. Here the AQI is very important. Air quality index is very important. Moreover, the suit with which the engineers wearing is known as, it's a bunny suit. It's known as bunny suit. And the temperature maintained is maybe, I think it's a 4 degrees centigrade, I think. These are units. These are units for testing purpose. These are the units for testing purpose. What they are testing here, an IC which is heated up to 200 degrees centigrade, for 3 to 4 days. Remember, 3 to 4 days. After 3 to 4 days, they remove that integrated circuit. They test once again. If the testing is passed, then only they give it for it goes to further fabrication. That is for the number of ICs, maybe 1,000, 10,000, 10 power 6, 10 power 8 ICs. If it is not tested properly, if the fault occurs, then it is once again goes to the first one, that is specification part. Once again, everything has to be done. And in these machines, one of the machines is a vibratory machine which pumps that integrated circuit almost for 10,000 times, more than 10,000 times. So nothing but it's a vibrator. Whether the integrated circuit, whether the tested IC is working properly after 10,000 vibrations. Now, something which I have just a package. What is that one? So what is that? Dicing is nothing but cutting whatever that square shape is there. This one. Dicing is nothing but, you may say use the word slicing. You may use the word slicing, but in integrated circuit, slicing is used for some other technique in FPGA. So that's why dicing is the word used. So take it. This is one. Next, mounting. Already I said mounting is nothing but nowadays surface mount technology. And while bonding, that your thing is the IC is wide, further that is molded, that is means permanently fixed on it. Then if any other ends are there, they are trimmed. Then go to functional verification, inspection, that is okay. Now, this is the entire process. And what are the job categories, career objectives are, here I have mentioned everything. The different categories, front end and back end. Further, if I go to a bit more previous one, then what is the nature, how we started, everything is given here. And what are the various aspects here, power, speed, size is already explained. And IP. IP is nothing but intellectual property. If you go through the company, Intel or i3, i5, i7, and take at the same time, take one computer manufacturer like Toshiba, or you may go with Dell or HP, they take Intel core processor, they pay some amount to that company. So this process is nothing but IP, purchasing that IP and using for their purpose. And nowadays the latest one is Snapdragon. For mobile phones, most of the time, it's a good one. Nowadays we are saying that one is a very good one from the Qualcomm company. Qualcomm Snapdragon 8th series, 5th generation. 5th generation. Of course, previous one is 4th generation is there. So they are nothing but IP of that company. You can purchase that one, you can use it for your process, but you have to pay some amount to that company. So nothing but IPs in nature. If you go through the what are the IPs here, that GPU, a graphical processor unit. Most of the time, this GPU nowadays is from the NVIDIA. The companies NVIDIA became very famous for the GPU, graphical processing unit. Even this NVIDIA company is richer than 120 countries in this world. Remember this point. NVIDIA is richer than 120 countries in this 120 countries in this world. And the economy of NVIDIA is greater than the GDP of India. GDP of India. That is the potential of NVIDIA company. NVIDIA. And of course, LPDDR3, nowadays we are coming with 4 and 5. In the 4, we have another category, 4X. Next, camera, we have seen Sony is one. The other one is CAR, called JICE, which is a very famous French. And that is France. Okay. And the display unit, we know what are the nowadays very famous means one directly say 4K or HD, 4K AMOLED screens, 4K AMOLED. Then security in the display is very important because we are using every transaction by using UPI. So security engine is very important. Where A53, these are nothing but they are name of the process. Name of the process. And just for your convenient purpose, how the server room, what is the mode of connectivity. So many processors will be there, nothing but stack of processors. This room is filled with stack of processors. Stack of processors. Stack of memory. Of course, there are so many connectivity, internet connectivity. These are the semiconductor area. This is very important for us today. 2022, our Honorable Prime Minister has started a very good project that is by 76,000 crores. Not only for the wafer fabrication, for making the display units also. And further, AMD came, AMD came to agreement with this concept. Semicon is one can go through this website from the Indian government. Semicon. Every year they conduct some congress, Semicon Congress. Next, Micron, one of the very good company for the making SSD, solid state devices and memory. India to become semiconductor capital. Of course, then the president of US is Joe Biden. 2.7 million Micron chip testing plan ahead of Modi's US visit. And AMD plans to invest 400 million in India. That is approximately 3,300 crores. This information is before 2 years. Actually, now it is twice. Okay, now what is this is from the Jack Kilby. This is what Jack Kilby has invented. Always one of the very famous person in the integrated circuit. Without him, nowadays the evolution of integrated circuit may not be possible up to this extent. May be possible, yes, definitely. If not Jack, some other person will be there. Maybe Jack Kilby at that time invented this integrated circuit, a 3-terminal device on a one platform. Then nowadays what we have is this one. IC technology development journey. We have seen in between what is that transistor diodes and so many things. Then there is ASIC FPGA. There are so many like SOCs, MP SOCs. Further, these are the integrated circuits. What we have with 10M to 100M transistors on a very tiny area. very tiny area. Just imagine the complexity of the semiconductor industry. An engineer, a BTech student, a MTech student, a researcher must be thorough in digital design and basic electronics. If you go to any company, they won't ask very, very big questions. Just what they ask is, assume that a D flip flop output is one of the D flip flop output, that is Q and Q bar, both are connected to one of the gate. One of the gate may be anything. Yeah, XOR gate, maybe XNOR gate. Further, the output is connected to input of the D flip flop. What is the nature of the circuit? This type of questions they ask. Further, a D flip flop output is connected directly to the input. This is one of the other question. Maybe other type. The Q bar is connected to input of the D flip flop. What is the nature of the circuit? Other words, 4 flip flops were connected in a synchronous manner, and the output is connected to once again the input of it. What is the nature of the circuit? The Q bar is connected to input of the first flip flop. What is the nature of this circuit? With very basic, what is the power equation? They ask on this one. Most of the students fail to address these very simple questions. The only thing is they lack interest in. They won't go through basics of electronics and digital design properly. The sum of products and product of some equation, how to convert from one form to another form. Then working with the D flip flops or SR, maybe T, maybe T, and the other one is converting from 1 bit adder to 1 bit adder, designing 1 bit adder using appropriate mux, and further designing some sort of a no, but I have 3/8 decoder. Asked a question, use 2/4 decoders to design 3/8 decoder, and I have 1 bit adder with me. Is it possible to design 1 bit adder by using a appropriate mux? So this way of conversion is very important. For engineers, because after the ending, the moment you become a coder or a very good designer, what you are going to use is set of muxes, set of multiplexers, and combination logic blocks and memory. And this is nothing but most of the time data. So this is about career opportunities and how the integrated circuit started. Depending on the company, core companies generally go with the bond. Some of the companies go with 4 years bond, and some of the companies go with 3 years bond. 3 to 4 years bond will be there. You have to execute that bond. Moreover, once you get into the company, they give training for 4 to 6 months, because that training costs you so much. So that's why you need to execute a bond. The basic pay may be at very beginning for moderate companies. I am not speaking about Cadence or Synopsys. Okay, 4.2 or 4 lakhs per annum. That is the CTC for. After this 4 years or 5 years, it will be somewhere around 2 digits. It depends upon how much you acquired in these 3 to 4 years. What is your skill set developed? How many tape outs you have gone through? Tape out is nothing but starting from the specification up to the GDS 2. Maybe it's difficult at this time using a word like tape out. Maybe in 4 to 5 years, if you stick to one company, you may get a chance to go through 1 or 2 tape outs. This is about journey of the integrated circuit and journey of the semiconductors. Yeah, questions are welcome. If you have any questions, you may proceed.
Thank you very much, Madhusudhan sir.
Sir, thank you, sir.
This is Nagreddy from MDCare.
Sir, good evening. How are you, sir?
Fine, sir. బాగున్నది
Sir, fine, sir.
అదే నేను కొద్ది లేట్ గా జాయిన్ అయ్యాను.
Sir, nice, sir.
అదే నేను వేరే వర్క్ లో ఉండి బిజీగా ఉండి చూసుకోవాలి.
Sir.
బాగా పర్లేదు.
Sir, అది sir.
ఓకే అది థ్యాంక్ యూ అది ఓకే ఓకే బాయ్.
Okay.
Any queries, sir? Anyone?
Particularly if any student community, I'm very much interested to address to students actually. Of course, anyone, of course, any student is interested. I'm very much interested to speak with you.
Okay, go for the next item. Felicitation to the speaker and the presentation of the memento. Anil? Anil? Madhusudan sir,
Thank you, sir. Thank you, sir.
thank you for accepting our invitation and the very informative speech about the semiconductors. Thank you very much, sir. And I thank all the chairman sir for giving me opportunity to act as convener of this event. And I thank our honorable secretary A.V. Naresh Babu sir. And I thank all who have joined this session. Thank you one and all. The next item is national anthem. Sir, Anil.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
జై హింద్.
So I am saying thank you to today's speaker, Madhusudan Reddy garu.